This is Algebra 1, lesson 8.3. We're doing division properties of exponents. A couple of goals we have, objectives. We're using division properties of exponents to evaluate powers and simplify expressions, and then we're going to use those to find probabilities. Beginning on page 463 in your textbook. We have a couple of definitions or a couple of properties that we're looking at. Division properties. Let A and B be numbers, and let M and N be integers. So we're not talking about any partial numbers, any fractions, anything for M and N. Quotient of powers property says to divide powers having the same base, subtract the exponents. On the last lesson, we talked about multiplication properties of exponents. Remember, multiplication pairs with addition. When you do the same bases, you add them. This right here is the division property. When you're dividing the same bases, you subtract them. So a to the m over a to the n is the same thing as a to the m minus n, where a is not equal to 0. Same thing with 3 to the 7th over 3 to the 5th. Division of the same base, 3, you subtract 7 minus 5, the exponents, and get 3 to the 2nd power. The power of a quotient property is just like when we did a power to a power. Remember, we treated it very similarly, or we acted like it was the distributive property. You're going to distribute the exponent to both of the numbers. So a over b to the m, a is going to get raised to the m, and b is going to get raised to the m. So that looks just like what we did. Okay, this is really simple. So the example, 4 over 5 to the third, 4 is being raised to the third, and 5 is being raised to the third. So simple. Again, it's not the distributive property. So if you write distributive property, technically you'll be wrong with that. But it acts just like it, and most people can compare it to that to where they can remember it very easily. Example number 1 is using the quotient of powers property. 8 to the 4th divided by 8 to the 3rd. Dividing the same base 8, you subtract 4 minus 3. Subtract the exponents. That gives you 8 to the 1st power, and anything to the 1st power is whatever it is. The second one, negative 7 to the 5th divided by negative 7 to the 5th. Again, you're dividing the same bases, negative 7. So dividing the same bases pairs with subtraction. You subtract the exponents, 5 minus 5. Negative 7, 5 minus 5 is to the 0 power. Remember, the second lesson we did this week said that anything to the 0 power is 1. Very simple. C says 5 to the 3rd times 5 over 5 to the 5th. Remember, there's an exponent in this spot right here. If you have to write it in, do so to where you don't forget it's there. It's the 1st power if there's nothing shown. That's the understood one. So you do the multiplication property first of exponents. You have the same base, 5 and 5. You add the exponents, 3 plus 1. That gives you 5 to the 4th. So now we have 5 to the 4th over, or 5 to the 4th divided by 5 to the 5th. Dividing the same base as 5, subtract the exponents, 4 minus 5. So 5 to the 4 minus 5 gives you 5 to the negative 1 power. Remember the second lesson we did with 0 and negative exponents. Anytime you have a negative exponent, you ride the elevator. If it's 5 to the negative 1, remember, if it's at the bottom of a fraction, bring it up. If it's at the top, bring it down. There's no fraction at all here. So just like when we do slope, we make a fraction by putting it over 1. 5 to the negative 1 is going to ride that elevator, or use the reciprocal, if you need to think of it that way, and go down to the bottom. So it'll be 5 to the positive 1 at the bottom. 1 is going to be on the top. So 1 over 5 to the positive 1 is simply 1 over 5, or 1/5. This one says 1 over x to the 7th times x to the 4th. You're going to multiply straight across. To get 1 times x to the 4th is simply x to the 4th over x to the 7th. Again, if you need to create a fraction out of this one just to see it better, do so. It's not a big deal. Once you have the same bases, x and x, you're subtracting them. 4 minus 7 is what you have. 4 minus 7 is x to the negative third. Again, elevator rule. If it's a negative exponent, it doesn't make the number, or in this case, the variable negative. It just makes it go to the other side of the fraction. In the numerator, go to the denominator, denominator, numerator. Remember, top go to the bottom, bottom go to the top. Right now, it's not a fraction. It's at the top. So put it at the bottom, and it becomes 1 over x to the third. Again, when it moves, when it goes from the top to the bottom or bottom to the top, you switch the sign. If it's negative, it becomes positive, 1 over x to the third. On the back, do this one. Take about 15 seconds. 4 to the fifth over 4 to the fourth. We're dividing the same bases. Both of them are 4. So you take 4 and you subtract the exponents. 5 minus 4. That's 4 to the first power, which is simply 4. Do this one. Negative 3 to the fourth divided by negative 3 to the fourth. Take another 15 seconds. So again, we got the same bases, negative 3 and negative 3. You're dividing them, so you subtract the exponents. You got negative 3 to the 4 minus 4. That's going to give you negative 3 to the 0 power. Remember, anything to the 0 power is 1. Do this one. 6 to the third times 6 to the fifth over 6 to the ninth. Take about 25 seconds on that one. At the top, you use the multiplication property. That's the same basis. Both of them are 6. Again, both of them are 6. Multiplying the same basis, that means you take 6 to the third plus 5 at the top, and you get 6 to the eighth power. It's over 6 to the ninth power. Now you have the same basis, 6, and they're dividing. So you subtract the exponents. This is what we're looking at today. This gives you 6 to the 8 minus 9, which is 6 to the negative 1 power. Remember, you can't leave something with a negative exponent unless you're talking specifically about scientific notation. So this has to ride the elevator. Instead of being at the top, remember, you're going to make it a fraction by putting it over 1. It's going to go down to the bottom, and it's going to become 1 over 6 to the first power, which is simply 1 over 6 for that one. There was a lot to do for that one. We have one more to look at real quick. 2 over x to the fourth times x squared. Take about 25 seconds on that one. So we got 2 over x to the fourth times x squared. Again, go straight across with it. 2 times x squared is simply 2x squared over 4x to, I'm sorry, x to the fourth times 1 is x to the fourth. So if you need a coefficient here, you can put it, but there's no reason to put 1 there. 2 divided by 1 is simply going to be 2. Now you have the same basis, x and x. They're dividing, so you subtract them. X to the 2 minus 4. That gives us 2x to the negative 2. Remember, you can't leave a negative exponent. But a couple of you guys were making mistakes on Monday with this. You were trying to make both of these things ride the elevator. Both of these are not being raised to the negative second power. Only x is. So put it over a 1 if you have to, and then ride the elevator only with the thing that is being raised to the negative exponent, x in this case. 2 is going to stay at the top, x is going to go down, and it's going to become to the positive 2 power. 2 over x squared. Example number 2 is using the power of a quotient property. Says simplify the expression, negative 8 over 5 to the negative third. Remember, that negative is out front of the fraction. It's in the middle. It's just rewritten down there by putting it at the top. Remember, it doesn't matter if you put your negative at the top or the bottom or the middle or whatever, as long as you don't put it on both parts, the top and the bottom, because that'll make a negative divided by negative, which will make it positive. It's easier, especially when you're dealing with slope, to keep your negative at the top. So negative 8 divided by 5 to the negative third. Remember, just like the distributive property, everything is getting a negative third power. This is getting it, and this is getting it. So negative 8 to the negative third and 5 to the negative third. Now, both of those are being raised to a negative exponent, which means both of them need to ride the elevator. Negative 8 needs to go down. Positive 5 needs to go up. Notice on this one, it just becomes a reciprocal, and the negatives become positive. 5 to the third over negative 8 to the third. 5 to the third is going to be 125. And negative 8 to the third, it's a negative value, and you have an odd exponent, 3. So it's going to be a negative at the end. 8 to the third, when you multiply 8 times itself 3 times, you get 512. So notice right here, going from this last part right here to the next one, it says 125 over negative 512. Remember I told you a little while ago that it doesn't matter where you put your negative. It makes it infinitely easier most of the time with slope to put it at the top. But it rewrites it for you. It's almost unnecessary to rewrite it in the middle there, negative 125 over 515, which 512. You just have to remember that the difference is you can't have the negative at both the top and the bottom. On the back again, 1 over 4 to the third power. Take 20 seconds. Okay, you have a 1 and you have a 4. Both of them are being raised to the third power. 1 to the third and 4 to the third. Doesn't matter how many times you raise 1 to a power, it's still going to be 1. 4 to the third power, 4 times itself twice is 16. Times itself one more time is 64. 1 over 64 for that one. The next one, negative, and notice where the negative is in this fraction, negative 4 over x squared. Take 20 seconds on that one. It shouldn't be too tough. Again, you need to ask yourself, what's being squared? Everything in the parentheses is being squared. That means 4 is being squared and x is being squared. So the whole thing is still negative up front. 4 squared is 16 on top over x squared. We don't know the value of x. It's a variable, so it's just x squared. And then negative comes back in because you do parentheses before you do the my dear part of please excuse my dear Aunt Sally. Negative 16 over x squared. And then what about 3 over 2 to the negative fourth? Take about 25 seconds on that one. Again, we have 3 over 2 to the negative fourth. Both terms are getting the negative fourth power. 3 is being raised to the negative fourth, and 2 is being raised to the negative fourth. Remember, they're both being raised to a negative exponent, which means both of them rides the elevator. 3 to the negative fourth goes down and becomes 3 to the positive fourth, and 2 to the negative fourth goes up and becomes 2 to the positive fourth. 2 to the fourth power means 2 times itself 4 times. 2 times 2 is 4 times 2 is 8 times 2 is 16. And 3 to the fourth, 3 times 3 is 9 times 3 is 27 times 3 is 81. 16 over 81. Example number 3 is simplifying these expressions. 3x to the fourth over 4x to the third times 12x to the third y squared over x squared. First thing you want to do is just says rewrite them next to each other. This is almost an unnecessary step. Multiply 3, your coefficients. 3 times 12, and you get 36. Then multiply your same bases. You have x, and you have x to the third. So you add 1 plus 3 in that case. If you have to rewrite it in, 1 plus 3, make it where you don't make a mistake. And you have y to the fourth and y squared. You add 4 plus 2 in that case to get 4 to the 6. That's why we get 36, x to the fourth, y to the 6. On the bottom, 4 is the only coefficient, so it's going to be 4. You have the same base as x to the third and x squared, so you add 3 plus 2 to get 4x to the fifth. Now we have 36 divided by 4. If you simplify that real quick, 36 divided by 4 is 9. X to the fourth divided by x to the fifth. Those are the same base. So you subtract 4 minus 5. That's where we get x to the negative 1. And y is the only y, so you don't subtract anything from it. Y to the 6. Notice now we have 9, x to the negative 1, y to the 6. The x to the negative 1 needs to ride the elevator and go to the bottom. Everything else is going to stay on the top. And it's going to be 9, y to the 6th over x. So 9y to the 6th over x. The second example, B, says 2x squared over y to the third to the fifth. Maybe anything inside the parentheses is getting raised to the fifth. It's like the distributive property. 2 to the fifth, x squared to the fifth. Remember, you multiply those two together. 2 times 5 to get 10. And y to the third to the fifth, same thing. Multiply 3 times 5 to get to the 15th. It's just rewritten right there, both of them being raised to the fifth. And again here, 2 to the fifth, x to the second times 5, y to the third times 5. When you multiply those two together, 2 to the fifth is going to give you the number 32, x to the 10th, y to the 15th. Again, that's all we can do with that. You do not subtract 10 minus 15 because x and y are not the same base. On the back, one more time. Simplify this expression, 3x to the third y over 4x times 12x squared y squared over y to the third. Take about 45 seconds on that one. Okay, if you multiply straight across, 3 times 12 is 36. 36, not 3x, 36. Then you have x to the third and x squared. You multiply those two same bases, you add x to the 3 plus 2 and y squared. That's y to the first power. So you add 1 plus 2. On the bottom, you do the same thing. There's only one coefficient 4. If you need to write in a 1 right there, you can. 4 times 1 is 4. And x and y are not the same base, so you don't add those exponents. It's simply x and y to the third. On top, 36 is staying just like it is. 36, x to the 3 plus 2 is x to the fifth. Y to the 1 plus 2 is y to the third. That's over 4x y to the third. So we have 36 divided by 4 is the number 9. And then x to the fifth divided by x to the first power. They're the same bases. You subtract them. 5 minus 1. And y to the third divided by y to the third, same bases. You subtract them. 3 minus 3. So you have 5 minus 1 and 3 minus 3. So it's 9. X to the 5 minus 1 is x to the 4th. And y to the 3 minus 3 is y to the 0. Remember, anything to the 0 power, in this case here, is simply 1. You're multiplying it times 1. 9 x to the 4th times 1 is simply 9 x to the 4th. One more problem. Let's check it out. Let's see how we can do. This one here, 3x squared over y to the 3rd power. Take another 45 seconds on that one. Again, everything inside the parentheses is getting raised to the 3rd power. So 3 to the 3rd power, x squared to the 3rd power. Remember, you have 2 and 3. A power to a power means to multiply them this time, not add them. And y on the bottom is raised to the 3rd power. So 3 to the 3rd power, 3 times 3 is 9, times 3 is 27. X to the 2 times 3 is x to the 6th, and y to the 3rd on the bottom. There's nothing else we can do with this problem because 27's dividing by 1 is going to stay the same. X to the 6th and y to the 3rd are not the same basis, so you do not subtract 6 minus 3. 27, x to the 6th, y to the 3rd is your solution.